I swim by their house every so often. Usually because the water around here, well, it's got manganese in it. You drink that and you start to lose your mind. Not that I had one to begin with. So whenever I go visit them, I bring water bottles with me, fill them up, and that way we have water for the cats and the dog and ourselves.
Good man, good man. There's if you're anywhere near Olympia, I know you can always also swing by the artisanal well, but that is I don't know if you're I don't know
Uh,
I forget if you're in Washington or not.
I am in Ohio.
Never mind then.
Yeah, I'm in Ohio. Um, yeah, that's why whenever you're saying 2 p.m. Pacific time, I'm like, okay, I can do that because it's 5 p.m. my time.
Gotcha. Oh God, I'm so sorry. I forget that Thursday is my day off and not the day off of teachers.
Oh no, I was looking at it like, okay, you were saying 2 p.m. your time, it's 5 p.m. my time, I'm good. By the way, if I sound a bit tired, it's because I fucking am, because fucking kids, god damn it.
Oh no, I understand. There's a reason I didn't finish my education degree. I was going to be
Yeah,
a high school English teacher, and that fell through.
yeah.
So, anyways, whenever you're ready, go ahead, share your screen. We will jump in. But before we do, feel free. Where can people find you online?
I don't really have any real presence online. I don't really have any YouTube channel or anything like that. I usually just lurk around and harass people.
Rad. Well, then, what we're going to do is we are going to spam the ever living daylights out of Dave with this presentation, and so take control of the screen whenever you're ready, and I will
Yeah.
go ahead and show it on the channel.
Let me do something real quick. I'm going to make sure that I get everything showing the way it should. And I need to get it open. I am still really fucking tired from school. Can you actually show on the correct screen presenter view? There we go. Alright, now swap screens, you stupid Google Slides. Yeah,
Well, it
that's
looks
why I
like
find it funny with Dave. When you saw I had slides, you could see he all of a sudden got shit terrified.
oh, 100%, 100%. For those of you who are watching who do not know who Dave is, he also goes by Lord of Patriarchy, and fuck that guy. Fuck him in the face.
Okay. And the reason I'm doing this, the reason this whole thing is going on, is because Dave has a huge fundamental misunderstanding of science, and it bleeds into everything he does. The reason this is important, and I picked this topic, is because Dave is using the fact that the ozone layer is no longer talked about as an excuse on why we shouldn't worry about climate change, and he, in his fundamental misunderstanding, bleeds into everything that he talks about with science. The fact that he gets this wrong is the simplest thing to Google because we've known this for 40 years now. Yes, I know, Onion, he's an idiot. My
This is
cat.
going to be amazing, and I love it.
It's not super long, which is why him kicking me off was the funniest shit because this isn't like a 5 hour long thing. I just threw it together during a lunch break because I was bored.
I've
Alright.
I've done something very similar, so no worries.
Yeah. So basically, I'm going to start off as if we hadn't had any discussion with him before. So I'm going to talk about the burden of proof real quick because that motherfucker needs to learn this shit too. So, I am making the claim here that the ozone layer didn't fix itself, hence my bit in my title. I have a burden of proof to meet because I am making the claim that it was our human action that solved it, and that we did not just, it could not fix itself, and it wouldn't have fixed itself without our intervention. Dave has claimed he never needs to cite his sources despite making claims, and he never meets his burden of proof. So I hope to show him today what burden of proof meeting looks like. I have sources for pretty much everything, and I can bring up any sources when challenged for it. So, first off, we need to talk about ozone. What is it and why does it matter? Ozone is oxygen 3. It resides in the stratosphere, and it helps block a good chunk of UV radiation, which causes skin cancer and a lot of other damage to our skin. No, Yazov, there will not be a test. But,
Nice.
so, it's created whenever, essentially, you get a certain nanometer wavelength of ultraviolet radiation hits an oxygen 2 and an oxygen, fuses them together to make O3, as you can see on the left. On the right, you get O3 when it gets hit by other nanometers of of UV radiation will split apart. This is what protects us from the UV radiation, because whenever it hits the O2 and O and makes O3, that absorbs the radiation to do it, and on the right, in order to break it, it absorbs the energy to break it, so it doesn't reach the surface. If the ozone layer were to disappear today, we would all be absolutely fucked. So, we would have no way to recover against this. No sunscreen on Earth would protect us from the incredible amount of UV radiation. Now, CFCs, what are they? Well, for the longest time, our refrigerants were either incredibly flammable or incredibly toxic. So either they would burn when they were released, or they would kill you when they were released. Either way, it would kill you.
I have a question on that. I'm sorry to interrupt.
Yeah.
But why would we use those?
Interrupt when you see need.
Why would we use a flammable refrigerant? I mean, like, wouldn't something that would be so combustible, like, not stop heat, would not, like, refrigerate things? Like, that's something it's always confused me.
If you keep it below the certain temperatures that it would be expected to run, as long as it keeps it within required temps, it's good. It's just once it were to leak, then it would be really bad. And the problem was, we didn't have much better. So you kind of got to go with what you go with. And if you don't want toxic, you got to go with flammable. So CFCs were very useful, and they were developed in 1928 by Thomas Midgley Jr. with General Motors. And it used chlorine, it used carbon and fluorine, and it was not flammable and it was non-toxic. So the only way this thing would burn is if basically the fire had already screwed the fridge over, and then it was bad. But if it was released, it wouldn't catch fire. It was very stable and it was very useful. And it was also used as a propellant in aerosols, because it made a very good aerosol because it wasn't flammable, so you didn't have to worry about catching fire and running back and blowing it up.
Oh, neat. Thank you.
Yeah, it's definitely a useful thing to know. Like I said, interrupt when you want. I'm not Dave. I love answering questions. And if I don't know, I got Google. So, what happens with CFCs, when they're in the atmosphere, they're fine until they get to the point where they go into the ozone layer. Because so much ozone so UV radiation's there, what will happen is the UV radiation hits the CFC and rips it apart. As you can see, I have a couple of the formulas that I found right there. I forgot to put my source on this one, so oh well. If you wish to get me on that, you can, but you can always. These are very easy to find chemical formulas. So it rips off that. Now this seems like it might also be good, because the chlorine being ripped off is absorbing UV radiation. But chlorine is a catalyst, so it'll react with ozone, and it challenges ozone to the glories of combat, and it rips through it like a knife fight, and it wins. And it keeps on going. So the chlorine goes through, it rips O3 apart, and then it just ditches the oxygen it leaves apart. And it goes across, and it starts doing it to everything else. The amount of time it takes for it to leave the ozone layer, on average, it can do anywhere from 10,000 to 100,000 molecules of oxygen 3. It can rip apart. Just one molecule of chlorine. So, you can see right here, I have a little bit more pictures of what it's doing. I do have a link for that, so therefore there is a link for it. So you can see, you have the UV radiation rips it apart. You get the CFCl2 off one end, you get a free chlorine, goes into ozone, it rips it apart, and then it gets chlorine monoxide, and it just breaks apart and keeps cutting them apart. It just splits, and it fucks shit up, which is a bad thing to have happen. Because I don't know about you, but I don't want skin cancer.
I've heard rumors that it's a bad time.
Yeah. So, we discovered the problem in the late 70s. We first published it in 1985 because we wanted to make sure what was going on and figure stuff out before it got released to the public. Because, we like to make sure of what's going on before we just shout to the void. So it was first published in the journal Nature, and I actually have right down here, if I remember it, I think that's the exact link to it, it has the link in it to it. I did find the original article. I can't remember if I linked it in the slide or if I just didn't. And even in as late as 2016, we got a bunch of, any time you get clouds in the stratosphere, they're gonna grab CFCs and yank it up there as well, and it's gonna kind of float around for a while. And even in Britain, we had small holes that were appearing as late as 2016, just because these clouds were happening in the ozone layer. And it would rip it apart, and we would still get issues with it. Now, they were small holes, and they went away when the clouds went away, but this is a problem because of how many CFCs, it still persists. This is something we're going to deal with for a while. It's getting better, but we're going to deal with it. Now, the way we responded it, the Montreal Protocol, first adopted in 1987 with a good chunk of the world. It wasn't the entire world, but then the entire world adopted it by 1990. This is the first treaty in the UN to ever get adopted by the entire world. This is the first time the world came together and said, we need to do something, and everyone agreed. I don't remember if anything else has happened since then, but it's the first, and it's one of the few. And that's what makes this so incredible. Yep, Canada definitely. So since its entry, about 98% of ozone-depleting materials have been removed from the atmosphere. So we are down to only 2% of what was there. And as a result, it's healing. We've replaced CFCs with HFCs, so simply just the chlorines now replaced with hydrogen. It does the similar job, and it doesn't deplete ozone, but it's still a greenhouse gas. It's worse than carbon dioxide, but we wanted to solve one problem, but we didn't want to have, another problem. We figured we kicked the can down the road on climate change. My brain's everywhere. Teaching, always fun. We kicked the can down the road on climate change to solve the problem that was immediate and pressing. Because at that point, this was 1990, we figured, in another 5 or 6 years, we'll be able to work together on something for climate.
That seems to always be the way of it, right? Like, we always just, like, we're like, you know what, we don't have, we could solve the problem, we could work and change to actually do something to fix it, or we could just ignore it and hope maybe it'll get a little bit better.
Oh, well, the thing was here, it was more of a case of the ozone layer was the bigger problem at the moment, and they figured, we'll get this problem solved, then we're going to work on climate change, we'll get that taken care of, we'll have it done by the year 2000, we'll get it done, but we need to solve number one.
Okay, so this kind of became like numero uno, because basically the sun is a deadly laser.
Yes, and this is a result in basically virtually the entire, a huge chunk of the Antarctic was just, there's very little to no ozone because of this. And the reason it was the Arctic, by the way, is because of the cold temperatures and the high stratospheric clouds that appear there led to that being accelerated there. Even the Arctic is a lot warmer than the Antarctic. So this happened in the Antarctic because of the unique temperature and cloud combination.
Gotcha. So that kind of became like a focusing beam for it.
Yeah, essentially, yes. So here we have, this was what was discovered in 1985. This was the hole in the ozone in 1985. You can see it was down to very low dangerous amounts. This is it at its highest in 1994.
Good Godfrey.
And this was it in 2013. It looks like it's expanding, but if you pay attention to a lot of what you see between 1994 here and 2013 here, on average you're seeing more of the higher concentrations and you're seeing lower, so it's actually getting better.
So I'm noticing... Oh, sorry.
Oh, go ahead.
I'm noticing that the high concentration zone is sort of encircling it. Is that kind of closing, is that kind of like sucking it in to kind of like replace the low concentration zone and kind of normalize it? Or is that just kind of going along with it?
I'm not sure. I've not looked into that part of it. So it is getting better. It's predicted to go to pre-1980 level by 2070, despite what Dave yelled. So yeah, by 1980 it should go to about pre-1980 level, but pre-1980 level is not 1928 level. We still have got a long way to go for then. So it's getting there, and it's a result of incredible, as you can see here, it's human effort that got us there. It wasn't just it doing it. We came together for the first time in one of the rare times as a world to go, this problem needs solved. Let's do it.
Human effort, baby. Humans will do it.
And these are the sources I use. Like I said, this is a pretty short little bit. These are all the sources I used, and I can open any of them up if people have questions. And the other thing I found is I found a few more additional reading. There's one bit right here that I found that's actually showing interesting things that I want to learn more about. The upper atmosphere is recovering, but the lower atmosphere is still going away at a faster rate than the upper stratosphere is recovering. So this leads to interesting things that I really haven't explored much, but it's looking like the lower ozone is still struggling and is getting worse faster than the upper ozone's recovering.
Fascinating. So we still have like there. It's kind of like we're trying to eat that whale and we've taken a couple bites, but there's still
Yeah.
a lot of whale to go.
Yes, and it looks like it's one of those problems that's going to be persisting for a very long time because of CFCs and similar chemicals like it.
Fascinating. Thank you so much for sharing this with us today. And
Yeah.
honestly, looking at the timer, like we started off with this just kind of bullshitting. It's only been 18 minutes, so like
Yeah.
this would have been like 10 minutes.
Yeah, like Dave was getting on about it being an hour. It wasn't. I put this together during a lunch break.
uh,
It wasn't designed, and I gave as you can see here with sources. I went in and I found these are all the sources I used, so that way I could always link to them up. If you have questions, I could pull one up, and then here are some other reading that we can look at that you can pull up and look. Now, I did want to address something that he said.
oh.
Is it still just showing my additional reading?
No, we're viewing we're viewing an article, and yeah,
Okay.
Fire, you're completely right. He would have made it an hour.
He would have, because he doesn't know how to shut the fuck up and just listen. He has to yell. So he made the claim that the ozone layer would fix it by 2040. So I Googled it, and this is the first thing I found out. Let me go to where it talks about it. So right here, what is the time frame for the ozone layer to be restored? This is the one, he said it was the first discovery, so this is my first one. So it says, although emissions of ozone-depleting stuff have dramatically declined, it will take many more years to recover. Globally, the ozone layer is expected to return to 1980 levels by 2040. The Antarctic hole will persist until 2066. Literally, the next sentence.
Literally the next second sentence. Good God.
And even if you look here on the little snippet, it's literally the next sentence on the snippet too.
I think it's just that we kind of expect 1980 is when people started paying a lot more attention, and so we have this very short-sighted view where, like, if a problem has not been going on for like hundreds of years, it's not a real problem. It's not something that we've been paying attention to, and we only start to really look and finding a solution at something we're actively paying attention to.
Mm-hmm. True. And the other thing Dave doesn't understand is because we no longer are hearing about the ozone layer because it's on the road to recovery, everything is looking good, we actually have done really good strides and it seems like it's on a good path. So we don't need to talk about it. And then he looks at climate change discussions where the climate change discussions are being updated because we're kind of doing something about it, so it's kicking the can down the road a little bit.
Right.
And and also we're getting better models to understand how it works better. Because originally we thought it was just global warming, and now we know that when it gets too warm, we're going to have another ice age, and the temperatures are just going to plummet. So he looks at this and the constantly adjusting view of climate change, and he thinks, oh well, we don't talk about ozone layer anymore. It went away on its own. This will go away on its own, because in his alcohol-filled mind, he thinks that, well, since this went away, this will go away. Because if I ignore my problems, they go away.
And I think I think the problem that we have a lot when we're talking about climate science is that it's a really complex and hard thing to understand. So people have this idea that, like, oh, I'm a pretty smart cookie, and I don't really understand everything that's going on. So if I don't understand it, obviously it can't be as big an issue, because obviously this just sounds like gobbledygook to me. Because people aren't willing to really have that thought of maybe, hey, if I don't understand it, I should actually talk to, like, I'm not a car guy, for example, but I'm not going to pretend because I can't understand how my engine works that somebody else doesn't.
Yeah, and that's why I'm deferring a lot to sources on it, because I understand some of how it works, but I want to make sure I resort to the people who actually put out articles on it. Because the fun part is, what people really didn't understand with climate change is once it gets too warm and the global and all the polar ice caps start melting, all that cold water is going to go into the ocean, which is going to disrupt all the ocean currents, which are required for bringing heat up north. And as those currents get colder and colder, the heat won't go up north as much, so the globe will start getting colder and colder. So they they think that, oh well, if it's the climate heats up, it's not going to cause an ice age, but they don't understand how interconnected our world is. And they also hear, oh, it's going to go up by 1 degree by this year, and they think, oh, 1 degree, that's not much, but they don't realize it's globally 1 degree, which is shit scary. Like a 2 degree increase is terrifying, to the point where, because it's not just like a 1 degree increase everywhere, it's the average. And with that 1 degree temperature increasing, it means that they're going to get places that shouldn't get heat getting heat and causing this acceleration process.
Oh, and I mean, we're already seeing that happen today. Like where I live,
Oh, we are.
where I live, like if it was an 80-degree summer, we called that a hot summer. That was back maybe 10 years ago. Now, if we have a summer where it doesn't hit in the high 90s, it's a cool summer. And this has been a decade.
And Euphemia, I agree with that too. Flooding is going to be a huge aspect, and it's going to result in, with all the extra energy on the planet, it's going to result in worse hurricanes, worse global, like, just environmental weather effects are going to get worse because of all the increased energy. We're going to get worse hurricanes, we're going to get worse weather systems. It's going to be chaos. And it already is. We're seeing it. Like, we haven't had, like, where I live, I remember every year it would start to get snow around Christmas time. Now we're lucky if it happens by February, if that.
Oh yeah, same here, same here. And I mean, you're in the Midwest for goodness sakes. Yeah. I'm on the fucking coast, and and we're seeing these heats. It's insane.
Yep. Like around here, like the fun part about the whole CFC issue is like my AC's been down for a year and a half now, 2 years, because I could get it fixed, but it actually will be cheaper to buy a new one, which I'm a teacher, I don't got that money, because my air conditioning was made pre-1989. It was made before all these restrictions, so it uses CFCs in it. And in order to actually get it repaired, I would have to completely have it rebuilt to run on the new stuff.
So that's actually kind of an interesting point to bring up. So, with the amount of, because I have to imagine there's a lot of people in that similar situation who, like, because the 1980s were, if we think about it, for building of houses where a lot of us live, because not a lot of us don't have, like, we're not, let's face it, no one watching me or watching us is going to be, like, super wealthy, so we all have houses built around that time period. So we're going to be seeing a lot of places that use those now banned technologies, and people aren't going to aren't going to be really quick about updating, and even updating is going to cost a huge amount of money.
Yeah, and when mine was having issues, they could still put CFCs in it. The problem is they're incredibly expensive. It cost me about $80 to put what would have been $15 to $20 of modern HFCs and similar.
Oh my.
It's that insane. And to fix this thing, like I said, it's going to require a complete overhaul of it, so much that putting a new one in is basically the same price, and it would be better for the house.
Gotcha. So it's kind of
yeah, go ahead.
Oh no, please continue.
Oh no, you go ahead.
So it's going to be like that. It's going to be like a massive investment. It's going to have to be made within our own infrastructure, and like getting that to update this. And it sounds like we're going to have to look into like some kind of bill that's going to end up being ridiculed, never pass Congress, because people are going to laugh about it.
Because Republicans.
Well, thank you. I know I'm mildly depressed, but you know what? I learned more, so I count this as a win.
Yeah. So it's definitely like I said, it wasn't super long, but it was gonna have Dave learn, and the fact that he's still running shit scared says everything you need to know. If he was super confident, why isn't he willing to have this discussion?
I think that's something that a lot of people need to be challenged to have this discussion, and I think we need to all kind of not be afraid to discuss climate change and discuss coming climate apocalypses. And I want to thank you so much for coming on today. This was a super fun conversation. I'd love to have a longer conversation in our private time, but I think 24 minutes is enough to spam him and be like, here, watch this.
Yeah. And really quick before I go though, too, the other fun thing, if Dave gets proven wrong, well, it's not that big of a deal for him because it was a science topic. If he has me on and can prove me wrong, he just proved a science teacher wrong. It's more damaging to my reputation, and I'm willing to go at any point in time.
You hear that,
Dave? That shows a lot about him.
You hear that, climate deniers? We're ready. We're willing. We've got the facts on our side. Prove us wrong, baby. Prove my boy Dargesh wrong.
Yep. I'm ready anytime. Well, thank you for having me on. I'm gonna duck out now so you can do your stream.